yesterday, we introduced the concept of a dihybrid cross. We've been talking previously about a cross of a trait, single trait, say eye color or hair color, or sponge color, sponge shape, star color, star shape. A single trait at once. And now we're going to step up our game and we're going to ask the question of what happens if I cross fur color and eye color, or star color and star shape, or sponge color and sponge shape, or tall-eyed crabs and red crabs. Okay? What we need to do now is figure out a way to get there. So we talked about the genotypes. We've done this. This is all monohybrid crosses. Of taking the two alleles here for fur color and figuring out what the genotype is, what we're going to see in the genes, the combinations of the alleles. So Gabby, what is one possible genotype you could have for fur color?
Big F, big F.
Big F, big F. Renata, what's another?
Big F, little F.
Big F, little F. Maynard, the third one. We have big F, big F, big F, little F.
Big F, little E, little E.
Well, we're not going to get there yet, so we're not combining them just yet. I just want the genotype independent.
Oh, little F, little F.
Excellent. Very good. And let's see here. Eye color. McKenna, what's one eye color genotype?
Biggie,
Biggie, Biggie. Amaya? Biggie, Little E, and Paris. Little E. Excellent. So those are the three genotypes we can have for each trait. What about the phenotype? What's the physical appearance of a big F, big F?
Brown.
Brown, right? If we're going to look at a fox, and its genotype is big F, because brown color is dominant, we're going to see brown fur color. Okay? Let's see here. In seed, what about a fox that has little e genotype for eye color? What's its phenotype going to be? Brown eyes? So, blue eyes, very good. So what I was going to say was that because big E is the dominant trait, if it's big E, we're going to see the dominant color. You corrected yourself there, very good. That it is actually little e is the only way we can have blue, because little e is the what trait? The recessive trait, excellent. Okay, perfect. And then we come together and we combine these using the distributive property. So we ran through this yesterday. We'll find that there are actually 9 different combinations, possible combinations of genotype we can have when we combine fur color with eye color. So big F, big E, big F, big E, little e, big F, little e, and then you do the same thing for big F, little f, and all the e's, and little f, and all the e's. Okay? There's a pattern of that. Okay? And the phenotypes combined, 4 different phenotypes. We can have brown fur with brown eyes, or brown fur with blue eyes, black fur with brown eyes, and black fur with blue eyes. Excellent. Okay. Let's see here. So, I'm going to cross a homozygous dominant, big F, big E, for fur color and eye color, with a homozygous recessive for fur color and eye color. So black fur, blue eyes, little e, little e. To figure out what goes on the side of my Punnett square, I use foil. You guys have all used foil before. I don't know, have you guys used foil? Is that something they teach you in middle school?
Yep.
No.
Yes.
Kind of, sort of, sometimes. Hope this monkey didn't eat that.
I remember it, but I'll show you.
So, big F, big E, foil. So first, outer, inner, last. So I take the first alleles of the F and the E, or the first genotype and the second genotype combined. Then I take the outer genotype, so big F with big E, the inner genotype, big F with big E, and the last genotype, big F with big E. We'll generate these combinations. So big F, big E, big F, big E, big F, big E, and big F, big E. They're all the same because I am homozygous dominant. Same alleles for the same combinations. The same thing with the recessive. So if I had little f, little e, first, what would the first be? Little f, little e. The outer, little f, little e. The inner, little f, little e. And the last, little f, little e. Excellent. Okay. Look at that. Alright. So let's step this up a bit. What if I wanted to cross a heterozygous wolf with another heterozygous wolf? The answers are up there. I don't know why that's there. Let's run through this and see if we can figure it out. Oh my god. Big F, little f, big E, little e. Okay. Brandon, what is the first
Big F.
combination? So we're doing foil.
Big F, big E.
Big F, big E. The outer, Caitlin.
Big F, little E.
Big F, little e. Damiana, what's the inner?
Little E. No, big E, little F.
So what we want to do, yeah, right. Actually, let's put the F first, since it's the first trait. We'll put that one first. This is the one time where we violate that rule, where I said before, where we have the dominant before the recessive. Here, we can let that go and keep our traits in order. So what would it be?
Little E, big, little F.
Little f, big E. And the last, Tanya.
Little F, little E.
Little f, little e. So here, I talked before about the order in which we write these, that we have them as the dominant before the recessive. That was when we were doing our Punnett square crosses. When we're figuring out for dihybrids, it will help if you keep the traits in order. So even if I have a recessive trait before dominant trait, if I keep my traits in order, it will help when you do the cross. Keep things organized. Okay, excellent. And it would be the same thing for the other wolf, because they have the same phenotype. So our smart board would come in handy, because I can just write on there. Okay. What I will do is ask Mrs. Langley if I can have one next year.
No.
Alright, so put these letters back together. So what we're going to do is I'm going to take, it's going to take a minute. 2, 3, 5, 3, 4, 5. Hardest part about these is actually drawing the box. Okay, so now I'm going to take the combinations I generated before with my foil, keeping each parent on one side. One parent up here, one parent down here. Big F, big E, big F, little e. What goes here? Little f, little e, little f, big E. And little f, little e. And then the same thing down here. Big F, E. Apologize, it's getting hard to see. I'm going to get a whiteboard. Big F, little e. Little f, big E. And little f, little e. Okay. Let's see here. Big F, little f, big E, little e. Let's see here. This one, big F, little f, little e, little e. Alright, I'm going to have you guys come up in turn and fill in a box. Allie, one little e. Coming down, I have one little f, one little e. So the combination is big F, little f, big E, little e. Okay? Here,
Big F, little F.
big F, little f,
Big E,
big E, big E.
little F, little F. Big
Big F, little F.
Little e, little e.
Little e, little e.
Oh my goodness.
And over here.
Little F, little F.
Yep.
Big E, little e. Big E, little e.
Yep.
A, B,
Alright, now, that was the easy part.
Yeah.
Hard part you guys will practice on your sheet. It's figuring out what is the genotypic and phenotypic ratio for this cross.
Oh my god. This is mixed. Oh.
So I have how many possible genotypes? 9. How many possible phenotypes?
You want to start
Or
with now? Scale.
brown fur, brown eyes, brown fur, blue eyes, black fur, and black fur, blue eyes. So 4 possible phenotypes. So what we have to do is figure out, okay, what is our genotypic phenotypic ratio? All I have to do is count. So how many big F, big E, biggies do I have? 1.
Two.
Where?
There, right next to it. No,
Where's there?
Where the
That.
red is.
Where your marker is. And then up. Left. Up. Up. Wait, what are we looking for?
Only one.
There's only one.
There's only one.
What are we looking for?
Big F, big E, big. Big F, little F, little E, little E.
Right there.
Only one.
I couldn't tell what we were looking for. I was like, wait.
They all look the same. Yeah, it does look
They do look the same, but they're not. I promise you they're not. Okay? Big F, big E, little E.
There's
One right there.
Two.
Big F, big E, little E. There's 2.
Three. No, that's not it.
Call this one 1.
Oh, I remember now because then they go diagonal.
Any other big F, big E, little E's?
No.
I don't think so.
No.
Last one. Okay? Big F, big E, little E.
1, 2. Wait, is that wait?
That's a little
No,
E.
that's a little e.
Oh, oops. Big F, big E, big E.
And then down there.
Up. Yeah, there.
There doesn't.
First row, third down.
First column.
First column.
Third down.
Third down. Yep. Okay. Big F, big E, little E.
Okay, what? 2 is right there.
3, 4.
4.
See, I told you they go diagonal.
They do. Big F, little E, little E.
Oh. It's over there only to the right. I think there's something. I think there's
No,
something.
there should only be one.
Big F, little E.
Yep.
Oh yeah.
There's only one.
There's only
No, down there. Oh, big F, never mind.
Yeah, sorry.
And big F, little E, little E.
There and then the bottom. Second column.
There.
Let's see here what's left to account for. Little F, big E.
That's the only one.
Only one. Little F, big E, little E.
The only 2 left.
1, 2.
2. The only one left.
No,
bottom.
right there too.
And now all you have to do is count them up. So yeah, it's a complicated ratio. Blue flowers are dominant to white flowers. Axial flowers are dominant to terminal flowers. So let's pick some alleles. What letters can I use to represent flower color? Eric.
B.
B. So big B represents what color flower? Blue. And little b represents what color flower? Axial and terminal. Pick a letter. Someone else beside there. And A. Big A represents what? Axial. And little a represents what? Terminal. So when we're picking our alleles, we're looking at our phenotype, our physical appearance, and saying, okay, I could be either or. Axial, capital A, big A. Terminal, little a. 2 choices. Okay. Flower color, blue or white. Alright, so we've done that. We've chosen our alleles. Now dominance. Alex? Dominance. What is dominant to what for flower color? Blue is dominant to white. Big B is position?
Axis.
Axial is dominant to terminal. Okay. Big A is dominant to little a. With me so far? Okay. I'm going to erase this, so I need room. Keep that in mind. Next, so we've done our dominants, we've done our alleles, now we need to do the genotypes. What are the possible genotypes for flower color?
Big B, big B.
So I'm going to take my combination of big B's and my combination of little B's. Okay. I can have big B, big B,
Big B, little b.
big B, little b, little b, little b. Okay. What about for flower position?
Big A, big A.
Look, I did it
Big
right.
A, little a. Little a, little a.
Or 16 and GC.
What are my possible phenotypes? What are the physical appearances I can have independently, right? Independent for flower color. Blue or white? What about for flower position? Axial or terminal? So blue or white for flower color, axial or terminal for flower position. That's my phenotype. I have either or. Independent. Okay. With me so far? Can I erase this? Okay. Now, this is where we're going to get into our dihybrids. Number one, now we want to find all the genotypes for both the traits combined. There should be none. Easy way to do this. First genotype here. Actually, let's go here. Big B, big B. What are the possible combinations I can have of the big B with my little b, with my A's? Excuse me. So big B, big B, big A, big A, big B, big B, big A, little a. Let me stop you guys there. So I'm taking one trait, I'm picking big B, and I'm combining it with the three possible big traits for flower position. Genotypes for flower position, I can say. So big B, big A, big A, big B, big A, little a, and big B,
Little a, little a.
good. What's next?
Big B, little b.
Big B, little b,
Big A, big A.
big A, big A, now what? Little B, little b, Jamie.
How come you just can't go in order from like big B, big B, little A, little A to
That is in order.
Hang on. Hang on.
how come in order fly?
Sorry?
How come you do in order?
When you do what?
Why couldn't you just go in order from big B, little A to big B, little B?
So go from here to here. So you're saying do big B, big A, big B, little b, big A, big A.
No, so if you did big B, little A, little A in the corner.
Yeah.
How come you can't go big B, little A, little A?
You could.
So can you skip our order?
In whatever order you want. You don't. This is not the set order to do it. However, it helps if you're keeping track and saying, okay, I'm going to pick my first genotype. I'm going to call that homozygous dominant for flower color, and combine that with all the possible ones I can have for flower position. Then I'm going to pick my second one, and then combine that in. Alright, we did not get to the quiz today. We'll get to it tomorrow. Please work on this. We'll have some time in class to do this.